In this video, we want to do some examples of finding the derivatives of exponential functions. So that would be finding the derivative of expressions like this, b raised to the x power. Remember, an exponential function is a function where the independent variable, in this case the x, is in the exponent's position. And one thing to keep in mind as we're differentiating these exponential expressions is that we can differentiate b raised to the x as long as b is greater than 0 and not equal to 1. And the derivative of b raised to the x is equal to b to the x times the ln of b. And here we want to find the derivative of y equals 7 raised to the x power. And here b, or the base of the exponential expression, is equal to 7. So y prime is equal to b to the x, which is 7 to the x, times ln of b. Again, b is 7, so that gives us 7 to the x times the ln of 7. And that's the derivative. In this example, we need to find the derivative of y equals 2 raised to the sum 3 plus sine x. And again, we'll use the derivative rule for the general exponential function. But notice that the general exponential function is a rule only for b raised to the x exponent, not b raised to a function of x. Here we have b raised to a function of x because 3 plus sine x is not just x, it's a function of x. So this example looks more like this: the derivative of b raised to an f of x. The derivative of an expression like this is very similar to the derivative of b to the x, but it looks just a little bit different. Whereas the derivative of b to the x contains a factor of b to the x, b raised to the f of x will contain a factor of b to the f of x. And that'll still be multiplied by the ln of b, and that's multiplied by f prime of x, where f prime of x is just the derivative of the exponent. Now this is an easy way to remember how to find the derivatives of these types of expressions. But really what this is an employment of the chain rule. If we were to apply the chain rule here, we would let u be equal to the exponent 3 plus sine x, and then y would be 2 to the u. And then of course we would find u prime and y prime and multiply those two together to get the derivative. But if we just remember that the derivative of b raised to any function of x is equal to b to that function of x times ln of b times f prime of x, we'll get the right answer. So y prime is equal to b raised to f of x, which is our original expression, times ln of b, and in this case our b is 2, so that'd be multiplied by ln 2, times the derivative of the exponent. The derivative of 3 plus sine x is cosine x. So we have our final derivative of 2 raised to the 3 plus sine x power times ln 2 times cosine x. All right, one more example. Here we need to find the derivative of y equals the quotient of 7 raised to the x power over 7 raised to the x power plus 2. This is a quotient, so let's use the quotient rule to differentiate. Using the quotient rule, f represents the numerator and g represents the denominator. The first thing we need is f prime times g. So the derivative of the numerator times the denominator. The derivative of the numerator is 7 to the x times ln 7. And that's multiplied by g, the denominator. And we subtract from that g prime times f. F is just 7 to the x. And we multiply that by g prime. G contains two terms, but the derivative of the second term, the 2, is 0. So all we need to do is differentiate the first term, 7 to the x. We've already done that. The derivative of 7 raised to the x power is 7 raised to the x times ln 7. And then that's all over g squared. So in the denominator we have 7 raised to the x plus 2 squared. Let's simplify the numerator by distributing 7 raised to the x ln 7 to 7 raised to the x. 7 to the x times 7 to the x gives us 7 to the x plus x, which is 7 raised to the 2x power. And that's still times ln 7. Now let's distribute to the 2. That gives us 2 times 7 raised to the x times ln 7. And now let's distribute to simplify the second term. Minus 7 raised to the x times 7 raised to the x is minus 7 raised to the x plus x, which is 2x. So that gives us minus 7 raised to the 2x, and that's still multiplied by ln 7. And that's still over the denominator squared. So 7 raised to the x plus 2 squared. Simplifying the numerator further, we see that 7 raised to the 2x times ln 7 and minus 7 raised to the 2x times ln 7 cancel out. And that leaves us with our final simplified derivative of 2 times 7 to the x times ln 7 in the numerator over the quantity 7 raised to the x plus 2 squared in the denominator.